All right, let's do some table work. We got Terre Haute for some years, and we're going to find the absolute change and the relative change. So you'll notice that these here are blacked out, and that's because in order to find the absolute change for 2000, we would need an old, right? Because this would be new, and we would need an old value, and we don't have one. So therefore, we cannot find anything for that piece. Now, when I'm finding this absolute change, that means 2005 is new, 2000 is old. So new minus old gives me an absolute change of 89. I take that and I divide it by the old, right? Because new minus old divided by old gives me my relative change, which is roughly 20.6%. And then, when I want to find 2010, this is new, now 2005 is old. So new minus old gives me an absolute change of 88. I divide that absolute change by the old in order to find my relative change of 16.9%. Again, when I go to the next piece, now this is new and this is old. So 678 minus 610 gives me an absolute change of 68. When I take that 68 and I divide it by the old value of 610, I get a relative change of 11.1%. Over what time period did Terre Haute have the greatest increase? Well, the greatest increase is here at 20.6%. So that's from the years 2000 to 2005. And yes, you need both of those pieces because we're talking it's that time frame. Referring to earlier FMR pages, I'm not really sure about any of this, but if we just calculate the absolute relative change from 2000 to 2015, 2000 to 2015, so that gives me 2000 is 433 and 2015 is 678. So the absolute change is 240, and the relative change would be 240 divided by 433 is 56.6%. Now, if you look at this, let me do a little erasing. If I sum up this column, I add these three together, I get 240, which is the same. So when I do the absolute change by year chunk, or I do them at one big time, I get the same thing. But if I add these together, I only get 20, 30, 40, 48.6, which is not equal to the 56.6 I got before, because if you think about it, when you're finding the relative change, we're dealing with different denominators. The numbers on the bottom are different for each one of these, so of course they're not going to be the same. So it is my understanding that the absolute change is the same, whether you're looking at chunks or one big piece, but the relative change is never going to be the same when you're looking at it that way. Okay, what is the estimated change in population of the state of Indiana in 2012? Now, if you're looking at this table is the annual change. So they are actually giving you the change. So if you look at 2012, the height of this bar is just over 20. So the change is roughly 21,000 because this table is in thousands. Is this absolute or relative? It's absolute because it's a concrete number. So we are dealing with 21,000 as the absolute change in the year 2012. So if the population in 2011 was 65,16,922, what's the population in 2012? Well, we just said that it increased by 21,000. So if I add 21,000 to that, I would get 6,537,922. And then let's write a meaningful sentence interpreting the relative change in the population for Indiana in 2012. Okay, so this last question I think is a little bit up to interpretation of how you're reading this, so I'm going to go the way I'm reading it. So your instructor may read it differently. But when you're talking about relative change, right, remember relative change is new minus old divided by old. And new minus old is the absolute change. Well, the way I read this table is they're giving you the change. So I feel like our absolute change for 2012 is 21. So what is our old value? Well, the previous change was 27. So I don't know if this is right, but I find this is roughly 77%. So in 2012, the increase is 77% of the increase in 2011, which makes sense to me, but I don't know if that's the way that the writer originally interpreted this question. So it's up for interpretation. It's up for, if you find a better way to describe that, somebody let me know, because that's the way I see it. And you know, sometimes when you see things one way, it's hard to see it a different way. So feel free to reach out and hook me up with something on that one. Let's go to the next question. To track the percentage of children receiving flu vaccinations, the CDC collects data early in the flu season and at the end of the flu season. Early in the season, 42% of children have been vaccinated, and by the end, 59.3%. So early is old, late in the season is new. So let's calculate the absolute change. 59 minus 3 minus 42.0 gives me 17.3 percentage points. So your meaningful sentence in the 14-15 flu season, there was an increase, forgot the N, an increase of 17.3 percentage points in flu vaccinations. There you go. Now let's talk relative change. Okay, so relative change, new minus old divided by old. So I get 17.3 divided by old, which is 42, and that is a 41.2%. So there was a 41.2% increase in flu vaccines from beginning to end of 14-15 flu season. And that is